Okay, back to it. What if we have an unknown angle? So this next problem I'm going to show you, let's just say they tell you that A is 40 degrees. Notice it's capital, it must be an angle. Little b is 15, lowercase is a side, and capital C is 65 degrees. That's actually enough information to what we call solve the triangle. That means to find the three unknown parts. In this case, two sides and an angle. Well, you might notice, you could draw this, but you really don't know what it's going to look like. So I don't really feel like we need to draw it. Let's switch colors here. But what I'd probably do first is find the unknown, angle, right? You could quickly find angle B is, see, that adds to 105, right? So it's going to be 75 degrees. I don't think you have to show your work on that, but box your answer. You have three answers, so make sure you box them. So without seeing that B equals 75 degrees, we don't have a known column. I should have said in the beginning. There is no known column here. But by getting this, we got our known column. The known column is of B's. So sine of 75 degrees over 15. There's our known column. We're going to use that twice. So to find A, we'd say sine of 40 degrees. You know what? I wrote this out, and we're not even going to do that. Okay, forget that. This is, I'll show you what this is in a second, but this is a second type of law of sines problem. It's probably, from initial perspective, it's indiscernible from what we did the first time. So anyway, forget this. But this is a problem that you can only do with law of sines. So our known column, and we put this over little a. And we cross multiply. A sine 75 degrees equals 15 sine 40 degrees. We divide by sine 75 and get some answer. And I haven't got a calculator, but what's that going to be? Well, you can look at it and see A is the smallest angle, so it should be the smallest side, so it's certainly going to be smaller than 15. Let's use the same known column. I'm going to use that again. So remember, law of sines is sine of any angle divided by its opposite side equals sine of any other angle divided by its opposite side, as long as they're within the same triangle. So to find C, we'll do this, cross multiply, and we get that C is 15 sine 65 degrees over sine 75 degrees. By the way, this step is not required. I would not do that step, but it might help you, so give it a try. So C, the angle C, or the side C should be, B should be the biggest side. They should both be less than 15, but side C should be bigger than side A. Okay, that's the basics of law of sines. And really what we've done, I didn't really say this, but we've done two cases. We've done the, make sure I'm getting these in the right order here. We did AAS. Remember this from proving triangles congruent? The very first problem, you had an angle, and a known side. Where was it? I was on the other page. Oh yeah, here we go. And this side. So you had your known column here, and you're good to go. You can find this, you can find this, then you can find that. So AAS, good law of sines candidate. And then we just did ASA. I didn't really draw it, but if we had drawn it, since I gave you, can we see all this? Yeah, I gave you, we just kind of guessed here. I gave you, let's call it angle B, A, and C. So I gave you angle A, side B, and angle C. Well, with that, you quickly get angle B, and you got your known column. So these two cases, AAS, ASA, you can use law of sines for, but don't think about that. Just think about the known column. Everything comes down to, do you have a known column If so, use law of sines. That's it. That's not in your book, but that's really the way to do it. If you don't have a known column, you must use law of cosines, which we're going to learn in 6.2. But there's one case we haven't mentioned. By the way, let me just make a list of the ways to prove triangles congruent. I'm sure you want to see this reviewed. SSS, SAS, ASA, and AAS. Now there's HL, but that's for right triangles. That's not going to interest us. So these 4 cases, we're going to talk about all of them. The first 2, and here's kind of the idea. Those prove triangles congruent. So if a triangle has those values fixed, then there must be a way, or the other 3 parts will also be fixed. If you have a fixed A, and a fixed S, the other 3 parts are fixed and they can be found. If you have a fixed A, a fixed S, a fixed A in that order, the other 3 parts can be found and they are fixed. So those last 2 we use law of sines for. The first 2 we'll explore in 6.2 and use law of cosines, because if you just look at it, if someone tells you, hey, these are congruent to the parts of another one, there's no known column. SAS, there's no known column. We'll explore that next time. So I guess we're done, right? We're done with 6.1? No. We're going to explore the often avoided case, the SSA. Okay, remember that from geometry, the SSA? Sometimes you might write it in different order where the A's in the front. Sometimes called the donkey theorem. I'm not going to do that. But I told you to avoid that in geometry because it did not work. And it doesn't work always. And we're going to talk about why. And we are going to actually use this case where there's 2 sides and an angle not included. And we're going to solve the triangle. But there are problems with it. And this is really what makes this section tricky. Let me see how we're doing on time. Okay, I think we're okay. So I'm going to try to explain this. Let's say you have an angle like 50 degrees. And this side is fixed right here, and it is 10. And this side, there's another side fixed, and it is right here, maybe, I don't know, what does that look like? We'll say it's 11. Okay, so you can see it's not really making a triangle, is it? So what I have to do is I have to take that 11 side and move it. This would be a good time for another color. So if I move 11 this way some, I can make a triangle. Let me redraw the triangle. It looks like this. 10, 50 degrees, and 11. It's an obtuse triangle. See the obtuse angle right there? But what if I were to take the 11 and put it this way? And so this little side here, you go at any length. And so that would be 10, oh, it's not really drawn very well, 11, and 50. So these 2 triangles have the same 2 sides and the same angle. They're in that SSA orientation, which means the A is not between the 2 sides. But they make 2 unique triangles. One of them is obtuse, and one of them is acute. And this is the problem with the SSA, and this is why SSA does not guarantee congruence. So we call this, it's a really fun name. This is how I learned this word. See if I can spell this right. Ambiguous case. Ambiguous means not clear. So if you have a fixed side, and angle is not included, it's not clear what your triangle is going to look like. You may have 2 possible solutions like this one had. You may have 0 solutions, or you could have exactly 1. So that's going to be the interesting thing about this. You can have 0, 1, or 2 solutions. And we're going to do one of each type of examples on this. So sometimes I call this, or some call it the swinging gate, because imagine this 11 side's like a gate, and as you swing it, here's like the hinge here, it follows like a path like that, right? And so here it touches the line, here it touches the line. So those are the two places you can make a triangle. Honestly, being able to draw this is not crucial. If you follow this system I'm going to show you next, I'm going to show you where you get 2, and I'm going to show you where you get 1, I'm going to show you where you get 0. If you follow my system, it'll work every time. I think the book is a bit unclear. If you follow their ways, they just kind of just assume you always know if there's 2, 1, or 0. My way, I'm going to assume 2, and as we go through, we might see, oh wait, it can't be 2. And I'll talk through that in the next video. See you next time.